Hi, today we're going to talk about the physics behind a handmade roller coaster.
So what we used on our experiment, the materials we used on our experiment were straws, marbles, um paper, used silicone, and also a cutter. That was really important to put everything together. And yeah, we used this to exemplify the principles of conservation of energy.
We made the hypothesis that the greater the height from which the marble is released, the greater its speed and kinetic energy. When it reaches the bottom of the track, it will also increase.
So our goal was to show how different height points, initial starting points to release the marble in our roller coaster affected the marble's final velocity. And yeah, we tried with this we tried to explain the principles of conservation of energy and potential and also kinetic energy. So a little bit further explanation about our project is the principle of conservation of energy, which has been already mentioned, which basically states that the energy can neither be destroyed nor created, only transformed. Um, Let me show you this. Let me show you what I mean with this. Yep. So basically, here we have a roller coaster track and a tiny card. So the energy right here would be potential energy. Absolutely everything would be potential energy in an ideal frictionless system. Yeah. So as it goes down the track, at some point here, like a here, like at some point in here, there will be no potential energy, and all that potential energy will be the potential energy that was here will be transformed into kinetic energy right here. And as it goes up again the track, it will become potential energy. Yeah, and it goes on and on like this forever, like in an ideal system, like I've mentioned before. So yeah, it is like some sort of balance. At the top of the track, this is potential energy and this is kinetic energy. At the top of the track, the potential energy will be like this, and as the cart goes down the track, it will become more or less like this, and it goes up again, and it will switch up again. Yeah, so that's a little bit of it. It is a little bit oversimplified, but yeah.
We built the track by carefully measuring heights and distances. We used a stopwatch to measure the time it took from the marble to go down the track from different heights.
So our variables were the initial height in the roller coaster where the marble was released, and the final velocity of the marble. So the our independent variable was the height, and the dependent was the marble's final velocity. Something that we did for our methodology was for each height we repeated the measurement 6 times, and then we took an average of the values we obtained to be a little bit more precise. And we applied formulas that were taught to us by our teacher um, to calculate the final velocity of the marble. Well, obviously to also to calculate the kinetic and potential energy in our system.
Our results confirmed our hypothesis. The greater the initial height means the greater speed.
Although there were things we didn't really took in account, like the friction between the marble and the roller coaster, the total energy remained almost the same, which basically proved the principle of the conservation of energy.
Our model is imperfect. Factors like imperfections in the cardboard, frictions, and small measurement errors affected the data, making the measurements not so precise.
Also, adding to the previous, In a real system, roller coasters in amusement parks are way more complicated than this naturally, and they're designed to work properly with the previous conditions mentioned, such as the friction, which is just basically loss of energy. Well, not a loss of energy, but it turns into heat and into other stuff. So yeah, we really couldn't replicate this, and it was a limitation in our experiment.
In conclusion, the project allowed us to see the transformation between potential and kinetic energy, and also to learn about the effects of non-conservative forces.
So to conclude with this video, I really think this experiment taught us the importance of using recycled materials, and yeah, because of global warming, and it's getting kind of bad over here. But yeah, I think it is really important, and also the advice of our teacher. And yeah, it was generally fun, and I really enjoyed it. And I assure you, I can say the same thing about my colleague.
Physics, in our daily lives, it doesn't discriminate, it doesn't care about social classes. Physics affects us all.
And that would be it for today. And thank you for joining us